Two important concepts about functions are noting their domain and their range. So let's talk about what those two things mean. The domain of a function is the possible x values that it is allowed to input into the function. So let's think of a really basic function like f of x equals x plus 2. Now you probably know that that just looks like a line, x plus 2. And anything you want to plug in for x, you will get an answer out. There's nothing that you would plug in for x and you couldn't get an answer, a y. So this has a domain of all real numbers, negative infinity to infinity, if you want to put it in interval notation, which is usually what you want to do for domains. But let's think about if we had a function like this. F of x equals 1 over x. 1 over x, it looks like a reciprocal graph. That's one of your parent functions. But let's think about what could we not plug in here. You can see that you have an x in the denominator and you can never divide by 0. So x being 0 is something that does not give you an answer. You can't have that in the function. So its domain is everything except 0, which looks like this. So what this means is anything from negative infinity up to 0, parentheses meaning not including, and then anything from 0 to infinity. So this means everything except 0 is allowed in this function. Your other type of function that could give you something that is missing from your domain is if you had a square root. Let's just say we had this one, f of x equals the square root of x. Now, if we're working in the real numbers, x has to be 0 or positive here. It can't be negative, so our domain would be 0 to infinity, this time with a bracket on 0, because you can take the square root of 0, it's 0, but you can't put in any negative numbers, so that would be your domain of this function. So that's what a domain is. So let's talk about the range. You might have guessed that the domain is the possible y value, or possible x values you can plug into a function. Your range is the possible y values that you can get out from your function. Now sometimes that's difficult to know by looking at a function algebraically. Typically a range is easier to find if you have the graph. But, for example, in our first one here, x plus 2, that's a line. We could plug in any x value and we could get any y value out on that line. This one's range is also negative infinity to infinity. Let's look at our function here, f of x equals 1 over x. Now we couldn't plug in 0. But you can think here, I could get any possible y value out that I wanted by plugging in fractions, negative numbers, anything like that, except the only thing you can't get here is 0, because 1 over anything is always going to exist as a number, either positive or negative. You can never get 0, so its range is actually the exact same. Everything except 0. And finally, let's look at this function up here, square root of x. Square root of x, again, we couldn't plug in any negative numbers. And when you have a square root function like that, the square root of any number is always going to be positive also. You can never get out any negative numbers. But you can get anything else you want. So this one's range is, again, the exact same as its domain. Now, the range and domain are not necessarily the same in general. That worked out the way that I did this one here. For example, let's say we took f of x 1 over x minus 3. Pretty similar to this function, except now your domain is that you can't include x equals 3, because that would make the denominator 0. However, the range is the same as it was here. You can get any number out except 0 for y, because 1 over anything would not give you 0. So that's how you calculate the domain